This video deals with the factor theorem, and the factor theorem is really just an extension of the remainder theorem. But in this case, we're aiming for the remainder to equal 0, thus proving that whatever we're trying is in fact a factor of our polynomial. So the factor theorem states that if p of a is equal to 0, then x minus a is a factor of p of x, meaning it goes in exactly. So when we divide, we'll expect 0 remainder. So our first example says apply the factor theorem to determine which of the following is a factor of x to the power of 4 minus 4x cubed minus 43x squared plus 58x plus 240. So we're going to try and see where the x plus 2 is, and what we want to show is that p of minus 2 is equal to 0. If p of minus 2 equals 0, then x plus 2 would be a factor. So we'll find what p of minus 2 actually equals. So it's going to be minus 2 to the power of 4, minus 4 times minus 2 cubed, minus 43 times minus 2 squared, plus 58 times minus 2, plus 240. So that'll be 16 plus 32 minus 172 minus 116 plus 240. And if you add all of that up, it equals 0. So we can make a statement, therefore, x plus 2 is a factor of x to the power of 4 minus 4x cubed minus 43x squared plus 58x plus 240. Okay, so same polynomial, x to the power of 4 minus 4x cubed minus 43x squared plus 58x plus 240. This time we want to see whether x minus 1 is in fact a factor of that polynomial. So what we want to prove is that p of 1 equals 0 if it's a factor, or if it's not a factor, it equals a number other than 0. So p of 1 will equal 1 to the power of 4 minus 4 times 1 cubed minus 43 times 1 squared plus 58 times 1 plus 240. So it's going to be 1 minus 4 minus 43 plus 58 plus 240. If you combine all that together, you get an answer of 252. We're not really interested in the magnitude of the number or whether it's positive or negative. If it's 0, we know it's a factor. In this case, it's not 0. So we would say, therefore, x minus 1 is not a factor of x to the power of 4 minus 4x cubed minus 43x squared plus 58x plus 240. Now, whilst we've practiced using the factor theorem to show whether something is or isn't a factor, the beauty, or why we would really use the factor theorem, is more to factorise our polynomials. We don't have nice rules like we did for quadratics, where we could use the quadratic formula or completing the square. We don't have any of those formulas, so we have to use long division in order to factorise it. And to start off, we want a factor that goes in exactly, so that's where we're going to use the factor theorem. So if we want to factorise using long division, we need to use the factor theorem first. So what we're looking at is values that go into, or numbers that go into, positive 30. So I'm going to see if 1 does. So we'd have 1 cubed minus 19 times 1 plus 30. And that equals 12. So we can automatically eliminate x minus 1 as a factor. Now obviously the more factors that last digit has, the plus 30 in this case, the more hit and miss things are going to be. I'm going to try p of 2, and sometimes you just have to keep working at it until you actually get one. So it'll be 2 cubed minus 19 times 2 plus 30. And luckily, this does equal 0. So that means that x minus 2 is a factor. What that means for us now is that we're going to have to use division of polynomials to find the other factors. Okay, so we're going to divide x minus 2 into x cubed. Now there's no x squared term, but I would be putting in a 0x squared term, so your columns all line up nicely. Minus 19x plus 30. And if we do the division, x into x cubed goes x squared. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. Subtract. X cubed take away x cubed is nothing. 0 minus 2x squared will become positive 2x squared. Bring down the other two terms. 2x squared divided by x is 2x. 2x times x is 2x squared. 2x times minus 2 is minus 4x. So you can see that the process of division is just a fairly repetitive process. We're doing the same things over and over again. 2x squared take away 2x squared is nothing. Minus 19x minus 4x, so it becomes minus 19x plus 4x will be minus 15x. Bring down the 30. Minus 15x divided by x is minus 15. So that becomes minus 15x plus 30. We subtract that. Minus 15x minus 15x is 0. 30 minus 30 is also 0. So that gives us factors of x squared plus 2x minus 15 is our quadratic factor, and x minus 2 is our linear factor. Now we need to fully factorise this. So our factors are x minus 2, x squared plus 2x minus 15. So the x minus 2 is already factorised, and the x squared plus 2x minus 15 we would factorise in the normal way. So it's multiply to give, add to give. So multiply to give minus 15, add to give positive 2. So it would be positive 5 and negative 3. Okay, and you can see that the process of long division, especially when you don't know a starting factor, can be quite involved. So we're going to have a quick look at something called short division in the next example. Okay, so we're going to use the process of short division to factorise p of x equals x cubed plus 2x squared minus 13x plus 10. This one is I think you either like it or you don't like it. So the only good thing about it is it takes up less space and less time, but sometimes it's a little bit difficult to get your head around. So you may want to practice the skill of long division before you bother trying to practice the short division. It starts off the same way. We need to find a factor, and we do that using the factor theorem. And so I'm looking for factors of positive 10. So I try 1, so I've got 1 cubed plus 2 times 1 squared minus 13 times 1 plus 10, and that equals 0. So I know that x minus 1 is a factor. Now this is where it differs from before. And now I can split my polynomial up to be p of x is equal to x minus 1 multiplied by a quadratic. But if I think of this quadratic, I know a couple of things. I know that this term here, or the first term in my quadratic, needs to be x squared because x times x squared has to equal x cubed. Using the same sort of logic, I can work out that the last term needs to be minus 10 because minus 1 times minus 10 has to equal plus 10. Then it becomes a case of trying to work out the middle term. Now the middle term, not as difficult as you think. We've got a 2x squared up here. So I've got minus 1x squared already. So to get back to positive 2x squared, I need to multiply by, or the x term, by 3x. Because x times 3x will give me 3x squared, minus 1 times x squared will give me minus 1x squared, leading me back to the positive 2x squared. As I said, this one is a little bit hard to get your head around. It's a lot easier, but it's a little bit trickier. So if you don't like it, until you sort of get your head around it, I wouldn't bother using it. It does save a lot of time. Now we have a linear factor here and a quadratic factor here. So the last step is the same as previous. I'm going to try and factorise my quadratic factor. So multiply to give minus 10, add to give plus 3. So it's going to be positive 5 and minus 2. That example concludes this video on the factor theorem. The factor theorem and the remainder theorem are both very important, especially when we start to look later on at sketching graphs of polynomial functions, so cubic functions and quartic functions. So it's really important that if you don't understand anything now, you do seek some assistance from your teacher. Good luck.